Hi everyone, and again welcome back to our lessons. Today we're looking at trigonometric equations where there's a restriction placed on the domain. Now for us to do that, we are going to look at the general solution again, and here is a trigonometric equation that you already know. Now in our previous lesson we worked it out and we got the following two general solutions. Now these two are the general solutions for this trigonometric function. Now what does these two general solutions mean? It means that we don't know for how far this function was actually drawn. In other words, technically these functions are drawn up to infinity and up to negative infinity. Now there's just way too many angles for that entire range for us to write down, and therefore we just have these two general solutions. But what happens if there is a restriction placed on the domain? Well, then we will not be asked the following question. We will not be asked to determine the general solution. We will rather be asked to solve for x, where x is an element of minus 270 degrees up to 180 degrees. Now this is the question, and this is the restriction of the domain for this example. Now, lucky for us, we are going to solve this equation as we usually do. So we go all the way and we find the general solutions. But here comes the difference. We're going to set up a table, and then here in the left corner we're going to write k, where k is this value in the general solution that tells us how many times we're going around our Cartesian plane. Now what I usually do is I choose my own values for k and I start with minus 2. Now minus 2 simply means that we're going around the Cartesian plane clockwise to incorporate all our negative angles twice. Minus 1 means we're going around only once, and 0 means that we haven't gone around once. 1 means that we're going around anti-clockwise to incorporate all our positive angles, and 2 is going around twice. Now sometimes we need to use minus 3 or 3 depending on our domain, but lucky for us, I think this will be enough for this example. Now what we do next is we take this general solution and we put it here in our table, and we also take the next general solution and we put it into our table. Now if there were 4 general solutions, they will also be placed in the table. And then I just simply take this minus 2 and I put it in the place of k. And now we're going to use our calculator. And then we get an answer of minus 690 degrees. We do the same for minus 1. We put it in the place of k. We get minus 330 degrees. Then we take 0 and put it in the place of k. We get 30 degrees. Then we take the 1 and put it in the place of k. We get 390 degrees. Then we take this 2 and put it in the place of k. And we get 750 degrees. Then we do the same for the other general solution. So we take the minus 2, put it in the place of k. We get minus 570 degrees. Then we take the minus 1, we put it in the place of k. And we get minus 210 degrees. Then we take the 0 and put it in the place of k. We get 150 degrees. Then we do the same with the 1, we put it in the place of k, and we get 510 degrees. And I'm not going to do it for the 2 because, as you can already see, these angles are way too big to fall in this domain. So this is all the different answers that we need, and now we simply go and look in these answers which ones or how many of these fall within this domain. So we've got 30 degrees, so I write it down. We've got minus 210 degrees, so I write it down. And we have 150 degrees, and we write it down. All 3 of these angles fall in that domain, so here is our values for x. I hope you could follow, and see you again next time. Bye!